Warahmatullahi wabarakatuh. Good morning, boys. I hope everybody is doing well, inshallah. By the grace of Allah, everybody's healthy, everybody's well. So, we're going to start the session, and um, we have received new instructions from the administration that everybody has to keep their webcams on. If the webcams are not on, you might be considered absent. Wa alaikum salam wa rahmatullah. Yes, I did, Hudhaifa, and I wasn't impressed. Not impressed at all. I'll tell you why. Because the way you are looking at the screen now, this is the expression you should be doing. There should be a spark in your eyes. There should be a smile in your face. You should be looking eager or excited or happy to do what you're doing. When I felt like you were a robot, you had no expression on the face, and you were too much consumed in timing with the music, which is not appropriate. So what you have to do is enjoy it. You weren't enjoying it. Sorry to say that. That's my feedback. That could be somebody else, somebody. Okay. So let's start. Let's see. So we were discussing about the nature of the matter. And for that, we'll have to open up the presentation. We'll have to continue from where we left. So nature of matter is like states of matter. Yes, we can do Kahoot, but we are a little bit too old for Kahoot, don't you think? We'll go to the GCSE pod. There we can have quizzes like Kahoot. So we can do something similar to Kahoot as well. And if you just give me a little bit time, I might be able to do the Kahoot, the IGSC pod today with you guys. Just one little minute. There's a small video on the topic. If we can use this, then I might be able to search the GCSE pod meanwhile. States of matter. Okay, it's a 5 minutes clip with the particle theory off. So this would be closer to the physics. Let's take this one. 1 minute, please, boys. Let me start a new share with the sound. All right, everybody can hear the voice?
Hi, welcome back to freesciencelessons.co.uk. By the end of this video, you should be able to describe how the particles are arranged in solids, liquids and gases, and how this arrangement changes during melting, freezing, boiling and condensing. You should then be able to explain why some substances have got higher melting and boiling points than others. And finally, if you're a higher tier student, you should be able to describe the limitations of this simple particle model. Now, there are three common states of matter, and I'm showing you them here. We've got solids, liquids and gases. As you can see, the particles are arranged differently in these three states of matter, and you need to be able to describe how they're arranged. We're going to start by looking at the features of solids and then explain these features using particle theory. Firstly, solids are extremely hard to compress, in other words squeeze. That's because the particles in a solid are packed together in a regular pattern with almost no spaces between the particles. Secondly, solids have a fixed shape and they cannot flow from place to place. That's because in a solid, the particles can vibrate, but they cannot move from place to place. Okay, let's look now at liquids. Just like solids, liquids are extremely hard to compress. And again, that's because the particles are close together, with not many spaces between them. Unlike solids, liquids take the shape of their container and they flow from place to place. That's because the particles in a liquid can move. Okay, we're going to look now at gases. Firstly, gases are extremely easy to compress. That's because the particles in gases are widely spaced. Secondly, gases spread out and fill the space of their container, and that's because the particles in a gas move quickly and randomly. Okay, now we can change the state of a substance by putting in or taking out energy. So we're going to look at that now. I'm showing you here a solid changing state to a liquid. This is called melting, and this takes place at the melting point. Now, as you can see, the particles in a liquid are moving around, so they've got more kinetic energy than the particles in a solid. This means that we've got to put energy in to convert a solid into a liquid. This energy is needed to break the forces of attraction between the particles in a solid. Once these forces are broken, the particles can now move around. In other words, we've changed the solid into a liquid. Now, there's one really important fact that you need to understand. The stronger the forces of attraction between the particles, the more energy we've got to put in to break them, and the higher the melting point. I'm showing you here a wax candle. Now, candle wax is a solid with a relatively low melting point, and that's because the forces of attraction between the particles are relatively weak, so they're fairly easy to break. This shows sodium chloride. In this case, the forces of attraction between the particles are very strong, so sodium chloride has a very high melting point. Going back to our diagram, if we convert a liquid back to a solid, then this is called freezing. This takes place at the same temperature as melting, in other words, the melting point. Okay, now we can also convert a liquid into a gas. This is called boiling, and this takes place at the boiling point. Just like before, if there are strong forces of attraction between the particles, then the boiling point will be high. That's because it takes a lot of energy to break those forces and boil a liquid. We can also convert a gas back to a liquid. This is called condensing. Condensing takes place at the same temperature as boiling, in other words, the boiling point. Okay, now if you're a higher tier student, then you need to be able to describe the limitations of the simple particle model of solids, liquids, and gases. So we're going to finish now by looking at that. Firstly, the simple particle model assumes that all particles are solid spheres. Now, this is simply not the case. Particles have got lots of different shapes, and they're not solid. Secondly, in the simple particle model shown here, it's assumed that there are no forces between the particles. Now, as we've seen, this is not correct. In fact, the forces between the particles have a major impact on the melting and boiling points of a substance. Remember, you'll find plenty of questions on states of matter in my revision workbook, and you can get that by clicking on the link above.
All right, controls. Okay, so going back to the presentation now. Let me share the screen of the presentation. We were on which slide? We were able to discuss the stars in the fifth state of matter. And I think over here, this was done. Yes, Basudi was reading it. Basudi, do you remember we did this? Yes, Bosenstein was done. Triplets was done. This one. So we'll start from this one. Let's start from here. Now solid, gas are in IGC. We took it grade 2 and 3. MashaAllah. I don't know which school did you go to, Abdul Wahab, but it's a part of the IGCSE. Okay, so let's give it to Abdul Wahab. He will read it for us.
Yes, Mr.
Yes, so would you like to read
Yes,
this?
sir. Energy and changes of state. A change of state is the change of substance from one physical state to another. A change of state requires a loss or gain of energy by substance particles.
Good, so how do you explain this?
What miss?
What do you understand from this slide?
Like the particle changes shape.
The particles change its shape.
No, the state.
The
The
state,
substance.
the
Substance.
substance. What is the substance?
Solid or liquid.
That is a state. Solid and liquid are states of a substance. What is a substance? It's a simple question. How do you define a substance? Abdul Wahab, can you hear me? Abdul Wahab, are you boys able to hear me? You can't hear my voice? The rest of the boys are raising your thumbs. So I'll text you, Abdul Wahab, I'll text you. How do you define a substance? Abdul Wahab has disappeared from the scene. Okay, let's put him to mute. He can't read the chat, he can't hear my voice. Okay, so who would like to explain that? What is a substance? It's a very simple question. Uzaifa is raising a hand. Yes, Uzaifa.
Yes.
You were raising a hand to answer.
Yeah, I was raising my hand.
So what's the answer to the question? What is a substance?
What is a substance?
Yes. How do you define a substance?
I find it nice.
You find it nice?
No, I find it quite good. I find it quite nice because of the substance I make. I find it quite.
How do you define? How do you define a substance? If somebody asks you what is a substance, how do you tell him? You tell him I find it quite nice.
No.
Then what would be your answer?
Define?
Yes. What is a substance?
Define a sub. That will. Give me a sec.
Okay, let me check Google.
It's the physical material or that of which an organ or body consists.
So this is the same answer Abdul Wahab gave me. It is a physical material, and this is the same. A substance is a matter. Matter. What's the matter with you? Not that matter. Anyway, the matter, which has mass and occupies some space.
Yeah.
It could be anything. A substance could be any object which has mass and occupies space, and it could be in any state. It could be a liquid state, it could be in a solid or gaseous state. Got it?
Yeah.
So this was a very simple question. It was like, so these are the objects. So the water is an object. It's a substance. These are the changing state. They're freezing and melting, evaporating, and changing their state from one form to another. So let's hear this. Where is Basyuri? Yes, Uzaifa, did you mute yourself? Oh, yes, you did. Yes, Abdul Wahab can hear me now. Good. So, Omar, I'll give you the mic. Where is Omar? Omar Bukhari, you have the mic. Would you like to read or you want to skip?
Okay, sure. Melting solid to liquid. Melting is the change of state in which a solid becomes a liquid by adding heat. The temperature at which a substance changes from a solid to a liquid is the melting point of the substance. For a solid to melt, particles must absorb energy.
All right. So how do you explain this in simple language?
I melt, let's say ice, for example. If I wanted to become water, I
Yes.
would have to put it in an area that is like warm enough
You have to
and
put
wait.
it in an area with?
That is warm enough.
Yes, warm enough. Good. Good point.
And I would have to wait for a while until it becomes fully water.
Right. So your particles are absorbing the energy from the environment, which is the warm environment, which shows the energy. So they will start moving faster and faster. They vibrate with more energy until they become liquid, until they can slide over each other. So good, excellent. Let's reverse it back. Yes, over.
Do I read this?
Yes, please.
Freezing, liquid to solid. Freezing is this change of state from a liquid to a solid. The temperature at which a liquid changes into a solid is the liquid's freezing point. For a liquid to freeze, energy must be removed from the liquids to slow the movement of the particles.
All right. So what was the important point in this slide?
Is that energy must is that the temperature that is changes the solid into
Yes,
a liquid into solid,
is it the increase in temperature or decrease in temperature?
decreasing temperature.
So I heard another voice. Somebody said increase. Or was that you?
No,
Okay, maybe I'm hearing things. Let me check if anybody else is mute.
my brother. No,
Oh, your brother. So Hamza says it's increase or decrease.
I didn't say anything.
He doesn't say anything. Okay. So it's gonna be decrease in temperature. That is true. We have to remove the energy from these particles. Once the energy is removed, they'll start moving slower and slower. And this will give them the opportunity to come closer to each other. Once they get closer to each other, they develop attraction towards each other. Once the attraction starts developing, they become more nearer until they are solid. They're tightly packed with each other. So that's the freezing point where the molecules have given up their energy and they are not sliding over each other and they're at their fixed places. So thank you, Albert. Thank you very much for your participation. We have Hudhaifa now. Hudhaifa, yes, you're raising a hand.
Yes, I wanted to read.
You can read, can you?
All right. Evaporation, liquid to gas. Evaporation is the change of state from a liquid to a gas. Boiling is the change of a liquid to a vapor or gas. The temperature at which this change happens is the boiling point. Water boils more easily if the at- atmospheric pressure is lower.
Okay, now this is not the appropriate definition for boiling. The boiling has a much better definition, and it has to do a lot with the what do you call it? With the external pressure, the atmospheric pressure. Oops, sorry. The atmospheric pressure is the wind pressure that is falling onto the onto the water. We say once that the amount of water vapors which is coming from the liquid is equivalent to the atmospheric pressure, you have reached the boiling point. Do you understand this phenomenon? Evaporation is happening at all temperatures, right? At all different temperatures. But the boiling is the change of a liquid into vapors, and the vapors start coming out of that liquid, and they are opposing the pressure of the atmosphere. When their pressure is equal to the atmospheric pressure, which is 1 atmosphere in our units, we say it's 1 atms, 1 atmospheric pressure. If the boiling water vapors, gas vapors are equal to that pressure, then you have achieved your boiling point. This can be, easily achieved if we reduce the atmospheric pressure, if we take away, if we create a little bit of vacuum, you will see that the water will start boiling at a lesser temperature and it will boil early as well. The opposite is of the pressure cooker. If we apply atmospheric pressure 10 times, what's going to happen? The evaporation and the boiling will take more intense effect, and then you will going to reach to a boiling point far more with difficulty as compared to with 1 atmosphere. So let's go to the next slide, which is condensation. Okay, Huzaifa has raised his hand again. So Huzaifa, you have the mic.
Okay. Mister, should I read or?
Should I read or?
I mean, shall I should I? Do you want me to read the slide?
Or what's the second option?
I want to read. I love reading.
What's the second option?
Oh, what do you want me to explain it?
Yes, yes. Read and explain, please.
Okay. Condensation, gas to liquid. Condensation is the change of state from a gas to a liquid. Condensation and evaporation are the reverse of each other. The condensation point is the temperature at which a gas becomes a liquid. For condensation to occur, energy must be removed from the gas to slow the movement of the particles.
So your explanation is?
I can't explain much.
Try to.
It says like condensation can change the state from the gas to liquid. And I don't know how to explain much. I'm sorry. I can't.
Give me an example. Give me an example of changing of gas to a liquid.
Like water.
Water is liquid.
I mean gas, like air, water vapor.
Water vapor is gas, all right. So connect the dots.
And carbon dioxide is gas.
Yes, that's true.
And carbon monoxide.
So how can I change the gas to a liquid?
I think you put in some. I think you put water in it.
Zaifa, you have water vapors with you. How can we change it to liquid, into water?
Maybe you put it. I don't know. Maybe you put some water. You put water in it.
Why would I put some water in it?
I mean, I know I can't explain much about.
Well, you have to reason it. We have discussed it so many times. We saw the pictures, we saw the videos. We're looking at the molecules of the gas. They are very far apart from each other. They're moving very fast. They have high energy. What should I do with those fast moving molecules of a gas, of water vapors, to make it liquid water?
Oh. Yeah, oil.
Hamza Bukhari is raising a hand, or is it covering the camera? Yes, Uzaifa. It's very simple.
You put it on the low temperature. You put it in a low temperature.
How can I do that? You are right that we have to decrease the temperature, lower temperature.
Because you decrease the temperature and maybe the gas will start forming into a liquid.
Why?
Because the temperature will be not It will not be so severe. It'll be normal.
Where are you reading it from?
I list the second part there. The second part.
So we are looking at the molecules. They will start attracting each other. They
I
start.
really like you. I really
We
like you.
are starting to attract each other. If you imagine there are a lot of boys running around very fast in a room, and you ask them to move slower, and they have to grab each other's shirt as well or hands and to stop each other's movement. If we stop decreasing their movement, if we stop making them move faster, we make them slower and slower, eventually they're just going to sit down and hold each other's hand and become like solid. So this is the whole scenario. The molecules are moving very fast. They're colliding very fast. If we decrease the temperature, we decrease their speed. Once you decrease their speed, they'll start attracting each other. They'll start binding bonds with each other. And they start sliding over each other. This is liquid. And once they are completely stopped, it becomes a solid. Right?
Yeah.
Make sense?
Yes.
Okay. So let's go to the next slide. I'll give this slide to Hamza. So let's go to Hamza. Where is Hamza? Hamza Bukhari, you have the mic.
Hello. Sublimation to solid to gas.
Yes.
Sublimation is the change of state in which a solid changes directly to a gas. In sublimation, the particle must go from being very tightly packed to being spread far apart. For sublimation to occur, the solid must gain energy for the particles to overcome their attraction.
So how would you put it in simple English?
Sublimation means it skips, like, you need to turn like it can turn solid to gas. It doesn't need to go to solid from solid to liquid. It can go from solid to gas.
Perfect.
This,
And why is this happening?
I don't know, how does it work.
Okay.
Maybe it's from the energy.
Yes, it is from the energy. That is right.
Gain a lot of energy, like kinetic energy.
Exactly. Once you give a little bit of energy, they go into complete freedom, as if they're being released from a jail. Everybody runs wild, as far away from each other. Imagine you have a lot of prisoners in a jail, and you open up the gates and you say, okay, you can stay in a park for 2 hours and come back. So they'll run for it. So they don't just slide over each other like the particles in a liquid, they're sliding over each other. Instead of that, they straight away go as far from each other as possible. They gain the energy really fast and they move really fast. So instead of becoming a liquid, they straight away become a gas.
For example, Donald Trump, he becomes the president. He becomes an idiot very quick.
Oh, that's true. But we are talking about the movement only, no psychological effects. So what is happening here?
Plasma consists of collection of free moving electrons and ions. Atoms have lost electrons.
Okay, plasma consists of collection of free moving electrons and sometimes ions. What is an ion? The definition of ion is atoms that have lost electrons or maybe gained an electron. So both makes, the negative ion is by gaining atom and the positive ion is by losing electron.
Oh, okay.
Right? So either you have a lot of free electrons moving, that could be electricity as well, and you have ions moving around. So the neon signs and the plasma television, they have that technology where they're using these ions to reflect the colors. So when we are looking at them, we don't get much affected with our eyesight. That's the way they actually,
Again, negative is ions, right?
Sorry?
Negative is ions, right? Negative charge of energy.
Even positive. You have positive ion and you have negative ion. The positive ion it comes into existence because of losing an electron. And the negative ion comes into existence when they gain an electron. I'll tell you what the story is all about. Let me just grab the white pen, whiteboard.
Okay.
Look at this. I'll try to explain with this. Here's a atom. Here's a nucleus. Okay, so here's the. Let's say we have 3 electrons. So this is electron number 1. This is electron number 2, and this is electron number 3. If you're looking into the configuration, it has 3 protons, 3 neutrons, and 3 electrons. The electrons have the negative charge, the neutrons have no charge, and protons are positive charge. What will happen if I remove, let me just take away, if I remove this, now how it looks like. You got 3 protons, the 3 neutrons, and 2 electrons. In this scenario, the first scenario, if you're looking at it, the 3 protons and the 3 neutrons are actually canceling out each other's effect. They make it neutralized. Because you have 3 protons and 3 electrons, they're equal. In this scenario, who is more in power?
Protons.
Yes,
Protons.
so that's why they get the positive sign. That's why they become the star. So it becomes a positively charged ion because the protons are more in number as compared to electrons. So the electrons do not dominate, it's the protons who are dominating. So these guys are in charge. So we call it a positive ion because it's losing one of the electrons. As it looks like kind of an egg, okay. So if we do the opposite, if you have 1 electron gain, then the electrons are more in number, so it becomes a negatively charged ion. Right? Does it make sense?
Yeah, I
Okay,
guess.
good. So let's go to this slide. What time we finished? 12:10? Well, 5 minutes. Okay. So
You want me to read it or what?
you are tired of reading, so we'll give it to Huzaifa.
No, no.
All right.
Okay.
So Hamza says no. Okay, Hamza.
All right. Fourth state plasma. Formed at high temperatures, ions phase of matter are found in the sun.
So what is found in the sun? The 4th state of matter. They're extremely high temperature, and they have ionized phase of matter. Okay. So let's go to next slide, and we'll give the mic to Hudhaifa.
Okay.
Thank you,
Yes,
Hamza.
thank you.
Thank you, Hamza.
Which
Yes.
slide do you want me to read on?
This one. Can you read this slide?
That's just a picture.
It's a beautiful picture, isn't it?
Yeah, look, it's a galaxy. Yeah.
Yeah. So they are showing the stars, right?
Yeah.
Or
They're
is it
showing.
the galaxy? I don't know.
I think I know it's a galaxy. I'm sure it's a galaxy.
Because we have found about 565 billion galaxies now. Amazing, isn't it?
But I don't see a single galaxy in Jeddah or anywhere.
You need to see through a Hubble telescope. You can't see it with any other normal telescope, but the Hubble telescope is good enough. So 565 billion galaxies. Imagine we are in just one Milky Way galaxy. So there are 565 billion galaxies like one of ours. Abdullah wants to go. Where do you want to go, Abdullah? I just wrote, can I go? Yes, Huzaifa, can you think?
Of an object, a glass.
That can act as a solid, liquid, and a gas.
Yeah.
Which one?
Glass.
Glass. I haven't seen glass as a gas.
Um, a knife.
I don't know. Let's check the answer over here. What do they have to say? I think the common answer would be water. So we have seen this one. When energy is added, particles move faster.
Water.
And what does this say now?
When energy is taken away, particles move slower.
Okay, he says it's the break time. Yes, is it break time? I thought 12:10 was the break time. So
Yeah.
okay, all right. So we'll stop the recording here.